In today's class, we continue to talk about the topic 2 instructions. We will finalize the section 2.7 and continue with the section 2.8. So again, you are required to read the corresponding material in order to get a better understanding of the material delivered in class. So near the end of the class, we mentioned it's not our MIPS 32 instruction not only limited by using equality for the conditional decision making, but potentially can be inequality, such as branch if less than, branch if less or equal to, branch if greater than, branch if greater or equal to. However, instead of create this kind of official instruction directly by using another instruction and less than to work together with branch if equal and branch if not equal to represent those meaning. However, the assembler still can understand those kind of instruction, although they are not included into the official instruction set. Therefore, we call those instruction as a pseudo instruction. Basically, you still can write the pseudo instruction, and the assembler will automatically convert the pseudo instruction by using a set of the official instructions. So near the end of that class, I ask how you can represent, if you assume yourself is assembler, how you can convert this pseudo instruction by using the set of official instructions. And for this one, actually, we're using this one as an example, right? So this one can be represented as the following. So basically is if S1 less than S2, I will update the general purpose register AT as a 1. Otherwise, AT will be 0. And then I will using branch if not equal. Basically, if A is 1, basically if S1 less than 2, then this is not equal. I will implement the instruction with the label. Overall, that means if S1 less than S2, I will implement the instruction. Otherwise, if S1 not less than S2, basically the general purpose register AT will be 0, then these two are equal, then this instruction will not be implemented. In other words, if S1 not less than S2, the instruction with the label will not be implemented. So you can see overall the set of the pair of set and less than and branch if not equal can work together to realize branch if less than. But here you might confuse a little bit because this general purpose register AT, which is called the assembler temporary register, you haven't seen that before. So this is the register directly or specifically reserved for the translation of the assembler. Just assume you're not using the assembler temporary register AT, you're using T0, there will be problem, right? Because this set and less than together with branch if not equal, is not represented explicitly in the sequence of sequence of instruction. In the sequence of instruction, what you see is a branch if less than. So in that way, if you're using T0 as an immediate general purpose register, that register potentially be currently used by other purpose. In that way, it will cause the value conflict. Therefore, instead of using other general purpose register as the immediate register for the assembler to do the translation, I will use this specific occupied or reserved register, an assembler temporal register. So that is only for this purpose. Okay. So, I highly suggest you practice how to represent branch if less or equal to, branch if greater than, branch if greater or equal to this pseudo instruction by using similar idea of the set of official instructions to represent. Okay, so now we already explained this. I just skip that. The question is why cannot the MIPS instruction just provide or include this kind of for instructions? Why do not do that? Why instead they implement or include another instruction set on less than. The reason is in the integer implementation, branch if equal then and branch if not equal, these two are much more widely used compared with all those instructions or those conditions. And by including this kind of conditional decision making into the official set, potentially enlarge the overall clock cycle of the implementation. Let me just represent one more time. Because those conditional decision making is much complex with compared with branch if then, branch if equal or branch if not equal. In other words, in order to finish those kind of comparison, you have to make the decision on whether I will do the control transfer for the instruction with the label will take much longer time compared with implementing branch if equal or branch if not equal. Okay, therefore, if I include those four together into the instruction set, and we all know all the instruction will have the unified clock cycle if we want to do the sequential implementation or called single cycle implementation, then although the branch if equal or branch if not equal do not need that much time to complete, but still need to wait there until those instructions will complete their implementation. So by doing so, overall, the whole performance will be reduced, especially those instructions are rarely used compared with the branch if equal, branch if not equal. Therefore, if you recall, one of the principle is try to make the common part faster, or improve the common part. Therefore, because the branch if equal, branch if not equal are the common one, we want to improve that or ensure the performance that rather than including this. So instead, we will including another instruction set on less than to realize those functionality. Although together with the set on less than and the branch equal or branch if not equal will be take a longer time compared with those individual instruction, but they will only compromise the performance of the rarely used part rather than compromise the performance of the commonly used one. I hope this is clear to you. So here, just introduce another thing called basic blocks. So in order to optimize the performance of the overall procedure, we put some instructions together and then treat as a basic blocks. The property of the basic block is they not allow the intermediate input or intermediate output. Basically, the instructions included in the basic block will treat as a whole unit. They only allowed to be entered from outside or an exit from the outside, or enter from the beginning or exit from the ending. So they not allowed to the embedded branch, not allowed to branch target except the beginning. So by doing so, basically when the compiler see the sequence of the instruction, they will first identify the basic block, and then when they optimize, they will not optimize the implementation of the individual instruction. Instead, they will optimize the implementation based on or by using those basic block as the basic unit. By doing so, we potentially can improve the performance.